To week 4, lesson number 2. Let's get going and see what more real world applications we can work on. Today is mostly a review day, just a little bit of new stuff. So we have homework answers to go over, some review questions to do it. Of course, always praxis power. Announcements, least common multiple, greatest common factor, and factoring to discuss during class today. And today you're going to take your first quiz of the year, or a quiz is more to the point. Here's your homework answers. Take a look, see if there are any issues. Because we're not in an interactive class. By the way, I like these videos much more than an interactive class for almost everything. This is one of the things where being in an interactive classroom setting at a particular time, it would be beneficial. But that said, if you have any questions on how to do any of these problems, you can talk to each other. You can perhaps find your mistake looking at the answers now, or you can talk to me. Go ahead. You are, of course, on stop and start. Okay. Praxis power. Performance is a function of preparation. Some new kind of questions for you today. Question number 1. Stop and start for each of these guys. Okay, this is without a doubt a classic example of the distributive property. Now, I want you to know that these questions I actually got from an official praxis review document. So, anytime you see it look like this, it's all about the math portion of the praxis test. That's where I get the questions. Here we go. So what they're looking for you to do here is to distribute the 5. You don't have to write the 5 in front. You can write it at the end. So 5 times 4 times 17 is 20 times 17. And 5 times 3 times 25 is 15 times 25. So the correct answer is going to be choice C. There's the 5 times the 4, the 5 times the 3. Again, the 5 being distributed or given to the two terms, it is the distributive property. Write two expressions that are equivalent to 7 times 15n plus 11y. In other words, do what you think you should do. Okay, so I distribute and I get 7 times 15n plus 7 times 11y. Or I actually do the calculation and I get 105n plus 77y. 7 times 15 being 105 and 7 times 11 being 77. Okay, give this one a try. There are 3 methods for doing this question. Ultimately, we want to be able to write a word problem, like we've been doing in class, and solve it that way. But if we felt frustrated with word problems and it just wasn't clicking, we could always do guess and check and make a table. Guess and check works like this. I try each of the choices, 12, 13, 98, and hope one of them works. If not, then you might say, okay, we'll go with not enough information. At 13 weeks, Juan gets 20 plus 6 times 13, that's 98. And Angel gets 150 minus 13 times 4, that's also 98. So 13 weeks, choice B is the correct answer. If I make a table with the week number, and then I calculate Juan and I calculate Angel, I come out with 13 weeks, they both have 98. But ultimately, we really want to be able to do this with a word problem. So, if we let W be the number of weeks, then we can represent Juan as 20 plus 6W. You're saving. So when you're saving, you're adding up, and that's plus 6W. Juan, on the other hand, or Angel, I'm sorry, Angel, on the other hand, he's a lot like the government. And what he does is he spends. So Angel starts with $150 and spends $4 per week. So we've got 20 plus 6 times W and 150 minus 4 times W. We want to know when they are the same or equal. So remember, this is an opposite side, opposite operation situation. I add 4W to both sides. That gives me 20 plus 10W is 150. I subtract 20 from both sides. I get 10W is 130. Dividing by 10, W is 13. Okay, let's try to do it again. But this time, I changed the numbers a little bit. I want to see you try to do this one on your own. Go ahead. And I don't think there are any choices here, so you're going to have to do it with an equation. Okay, so the advanced or the algebraic method. 20 plus 4W, because he's saving $4 per week. And Angel has 150 and he's spending $1 a week. So it has to equal 150 minus 1W. Adding the W to both sides, 20 plus 5W is 150. Subtracting the 25W is 130. W is 26. So at 26 weeks, they would be even. Okay, Barbara's Catering Company makes the best fruit and salad despite using only 4 ingredients. Have at it. Remember, these are all old praxis questions. Stop and start time, and then I'll go over the correct way to do this. Okay, so, by the way, tonight is a Saturday night. My wife's not home. We just got some bad family news. She had to go away, and I'm a little bit tired, so you might hear me going a few times. All right, so there's 4 apples for every mango. Let A be apple, M be mango. 2 pears for every apple, and 1 pineapple for every mango. If they used 8 pineapples in their most recent batch, how many total pieces of fruit did they use? Now, the best way to do this is to diagram it out. Write it out. 1 pineapple for every mango. So if you have 8 pineapples, then you have 8 mangoes. Next up, there's 4 apples for every mango. So if you have 8 mangoes and every mango gets you 4 apples, 8 times 4 is 32 apples. But there's 2 pears for every apple. So if there's 32 apples, that means there's 64 pears. So we figured out how many pineapples, 8, how many mangoes, 8, how many apples, 32, and how many pears, 64. If I add them all up, I get 112 pieces of fruit. Okay, now try Barbara's Catering Company again, but we change it a little bit. Go ahead. Okay. 1 pineapple for every mango. So 8 pineapples, 8 mangoes. Nothing changes there. 3 apples for every mango. That changes. So with 8 mangoes, you're going to get 24 apples. 2 pears for every apple. So with 24 apples, you're going to get 48 pears. So I got 8 pineapples, 8 mangoes, 24 apples, 48 pears. Adding those all up, it's 88 pieces of fruit. Let's try this word problem. Go ahead. So, word problems are something that frustrates students very much, and we're going to do many of them throughout the course of this particular course because in real world problems, they're made up of a lot of word problems. So we have to have good strategies for this. So remember, underline everything you think is important here, okay? And then use it all when you write it out. So 3 consecutive even integers are important, and we know if they're even, they're x, x plus 2, and x plus 4. Now, the next thing is the last 3 consecutive even integers, and the last is equal to the second, the sum of 4 times the first and the last. So I got to do 4 times the first, and the last one, the x plus 4, is equal to the second increased by 42. So here's 4 times the first, here's the last, and that's the sum of 4 times the first and the last is the middle one increased by 42. Same side, same operation. Both sides you do this on. That's 5x plus 4 equals x plus 44. Subtracting the x from both sides, I get 4x plus 4 is 44. Subtracting 4, and I get 4x is 40. Dividing by 4, x is equal to 10. It's always comforting when that works out to be the kind of integer they're looking for, even or odd. And then the next ones would be 10 and 12. So 10, 12, and 14 are the correct answers. Let's have you try a perimeter problem. We did one of those the other day too. Okay, so there's a rectangle, and it says the length of the rectangle is 5 less than 7 times the width. So I have W and 7W minus 5. If the perimeter is 134. So the perimeter has 4 sides of the rectangle. We know when it says 5 less than 7 times the width, we see that phrase less than, last shall be first, first shall be last. Switch that order, I get 7W minus 5. So that gives me W plus 7W minus 5 plus the other width plus the other bottom is 134. Same side, same operation. That gives me 16W minus 10 is 134. Add 10 to both sides. 16W is 144. Dividing by 16W is 9. To get the length, remember it's 7 times W, the width, minus 5. So 7 times 9 is 63, minus 5 is 58. To get the area, I do length times width, which is 9 times 58, and that's 522. Okay. Now, how many people here believe in aliens or UFOs, those sorts of things? I don't really know, personally. I am convinced that most of the things that we call UFOs are indeed UFOs. They're unidentified. But that doesn't necessarily mean that there are little green spacemen in them or spacemen of any kind. What I'm confident saying is that there's some really advanced technology that our military works on, probably the military of other nations too, and we see them in the sky sometimes. But I can't rule out that there's aliens. I don't know if they're here or not. Now, one of the most famous stories about aliens is that a spacecraft crashed in Roswell, New Mexico. And all of a sudden, from the day that that spacecraft crashed, our technology, our abilities with technology, nanotechnology, everything else, has become unbelievably, we advanced so quickly. Now, does that mean there's aliens in Roswell? No, absolutely not. But the popular theory is that our government got a hold of the spacecraft and did something we call reverse engineering. What reverse engineering means is they got the spacecraft and then they went in and went backwards. They had the finished product and they worked backwards to see, well, how'd they put this whole thing together? And then they started using the technology. By the way, that little bit of snoring there is my dog. So when we start getting into this idea of factoring, we're getting into reverse engineering the distributed property. So let's just use the distributed property, if we can, to answer these 5 questions. Go ahead. Stop and start, of course. Okay, so that's 5A plus 10B, distributing the 5 to both. Now distributing the 3, 21N minus 12. Distributing the negative 2. Remember, when you multiply by a negative, you change every sign. So it's negative 2x minus 8y plus 10, right? Because I'm changing the x to a negative, the 4y to a negative, and the 5 to a positive. Try the next one. That would be negative 21x squared minus 28x plus 7. Same thing about changing all the signs. And the last one was distribute the 9 to all 3 terms. All 4 terms, sorry. That gives me 18x cubed plus 27x squared minus 36x plus 45. So that's distributing. And by this point in the course, I'm confident in believing that you are very good at distributing. Okay? Now, this number in front, the thing we distributed, the 5, the 3, the negative 2, the negative 7, and the 9, that's what we call a greatest common factor. And when we factor something, the first thing we look to do is pull out any common factors that we can find. So when we reverse engineer, they're going to give you 5A plus 10B. and we want to factor using the greatest common factor. But now they're going to give you what's in red. It's kind of like the game show Jeopardy, right? In Jeopardy, they give you the answers, and you're supposed to say the question. Like, for example, they'd say Abraham Lincoln, and you might say, who is the 16th president of the United States? Now, if they say 5A plus 10B and they tell you to factor it using the GCF, that means they want you to go backwards. They want you to start with the 5A plus 10B, pull out that greatest common factor, and come up with 5 times A plus 2B. Now, if you factor correctly with the GCF, when you distribute back, you should get back what you started with. 5 times A is 5A, 5 times 2B is 10B. Ding, 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 ding. Lights flash, bells ring. You did the correct factoring, okay? So we look for the greatest common factor. We pull it out. We get what we think is the answer. We're reverse engineering this, and then we check it by distributing back. It is almost always the case that if you made a mistake, it will become apparent to you when you multiply back. Just looking very quickly at the 21n minus 12, they 21 and 12 share 3 in common, so I factor out that 3. That's how it gets outside the parenthesis here. And I'm left with, factoring is division. 21 divided by 3 is 7n. 12 divided by 3 is negative 12 divided by 3 is negative 4. Distribute back and check. 3 times 7n is 21n. 3 times negative 4 is negative 12. Why is it doing that twice? I don't know. Okay, let's see you try numbers 1, 2, and 3. Go ahead. Numbers 1, 2, and 3. Now, in number 1, they distribute. They share 5 in common, so we distribute it. That's 5 times n minus 4. Remember, we are reverse engineering this, so distribute back with the 5. 5 times n is 5n. 5 times negative 4 is 20. I did it correctly. What's the greatest common factor of number 2? Now, number 2 is a little tricky because they share a 2 in common. They share a 3 in common. They share both terms. They share a 4. They share a 6. And they share a 12. And 12 is the greatest common factor. So we're going to pull out the 12. If I do 12g divided by 12, I get g. 24 divided by 12 is 2. Distribute back just to check. 12 times g is 12g. 12 times 2 is 24. For the next one, they share a 4 in common. So I factor out that 4. It's 4 times 3x plus 7. That would be 4 times 3x is 12x. 4 times 7 is 28. Try number 4 and then number 5. Don't do any more than that. 4 and 5. Okay, so in the first problem, number 4, they share a 5 in common. So I factor out that 5, I reverse engineer it from the distributing, and I get 5 times a minus 3b plus 2c. Let's check ourselves. 5 times a is 5a. 5 times negative 3b is negative 15b, and 5 times 2c is 10c. I cannot emphasize enough just how important it is that you check yourself by distributing back. If you made a mistake, it usually is pretty obvious and you can correct it before it becomes a problem. Now, number 5 is different because for the first time, we have the same variable in both of them. So what they share in common here is a variable. Now remember, a squared is AA plus 3a. So they each have 1a. So I factor out the a that they each have. I'm left with a times a plus 3. A times a is a squared. A times 3 is 3a. It's a little bit different for students, but the easiest thing to remember here is you're always going to factor out the least number of any variable that they all have in common. They both have a's, and the smallest number is 1. So we factor it out. That word greatest sometimes makes us think we should choose the higher exponent. But we're not choosing the greatest. We're choosing the factor. Okay? So if it's not common to both, it can't be a factor to both. Common factor. And a squared is not common to both. Only 1a is common to both. Okay, try number 6. Let's see what you get there. Just number 6. Okay, so what do they share in common? They share an a in common. So I factor out the a. It was a squared, which is aa. I take one of them out. And negative 7a, I take that a out. Let's distribute back to check. A times a is a squared. A times negative 7 is negative 7a. Now, let's do number 7 together here. This is a new type. Not only do they share a 5 in common with the 5 and the 15, but they also share an a in common like we did in numbers 5 and 6. So for this one, we're going to factor out a 5a, and that leaves me with a plus 3. Check it out. 5a times a is 5a squared. 5a times 3 is 15a. Remember, it's the smallest exponent that they always share in common. So it's a to the first, not a to the second. Okay, you try number 8. Okay, so with number 8, they share a 5 in common and they share a single x. So I factor out the 5x, and that leaves me with 2x minus 5, right? 10 divided by 5 is 2. I pulled out one of the x's. 25 divided by 5 is 5. I pulled out the x. So 5x times 2x minus 5. And for some reason, the answer to number 9 appeared. So let's just confirm it. You'll notice on number 5 that even though one of the terms is squared and v squared and the other one has a v, the last one doesn't. So because of that, there is no common v. So the only thing common here is the number 3. So I factor out the 3 and I get v squared minus 3v minus 7. Now let's have you try number 10. Go ahead. Okay, now on number 10, and again, pause after each time, they share a pi in common and they share an r in common. Kind of weird to have a pi there, but they have it, so we're going to factor it out. I factor out the pi and a single r, because this is r squared, this is r to the first. We always want the lowest exponent of any variable. So pi r, if I factor out those two, there's a single r left. If I factor out the pi r from pi r h, there's an h left. Distribute back to check yourself. Pi r times r is pi r squared. Pi r times h is pi r h. Try numbers 11 and 12. Go ahead. Okay. So on number 11, what do they share in common? They share a 4 in common. Yes, they also share a 2, but that's not the greatest common factor. That's a common factor. So they share a 4 in common, and each of them has an n, and the lowest exponent is an n squared. So my greatest common factor is 4n squared. Now, when I divide out a 4 from 8, I'm left with 2. When I take out or take away n squared from n to the third, by taking away, I mean I'm taking it away from the term and putting it outside in front. N to the fifth was n squared is n. I take out 2 of those 5 n's that were originally there. That leaves 3. And factoring is division, so it makes sense, right? 5 minus 2 is equal to 3, just like the laws of exponents for division. 20 divided by 4 is 5. It was n to the third. I'm taking away 2 of them, so that's n to the first. And negative 32 divided by 4 is negative 8, and both of those n's in the n squared, they came out factored. Now let's check ourselves by distributing back. 4n squared times 2n to the third is 8n to the fifth. 4n squared times 5n is 20n to the third. And 4n squared times negative 8 is negative 32n squared. Okay? Now, For number 12, what do they share in common? Well, they share a 3 and the single x this time. So I factor out the 3x, and that leaves me with 3x squared minus 7x plus 5. Let's distribute back. 3x times 3x squared is 9x to the third. 3x times negative 7 is negative 21x squared, and 3x times 5 is 15x. Okay, that is factoring with the greatest common factor. It's not the only kind of factoring we do in this course, though. Factoring is division. It's reverse engineering distributing. So we've been doing some double distributing, so we need to be able to factor situations that involve double distributing. All right, so here's number 1. What I would like you to do for numbers 1 through 6 is to double distribute each of them. Let's get a little practice with that, and then we're going to look for common trends. Go ahead. Okay, so you should have done stop and start, right? Which means that you've completed all of these exercises, even though only seconds have gone by in the video. In reality, a lot of time went by because you needed it to do these. Double distributing the first one, I get x squared plus 8x plus 15. Double distributing the second one, I get x squared plus 9x plus 14, right? Distributing the number 1, x times x is x squared, x times 5 is 5x's. Now I distribute the 3. 3 times x is 3x, 3 times 5 is 15. Combine those terms in the middle. 5x's plus 3x's are 8x's. X squared plus 8x plus 15. Perfect. For number 2, distributing the x, I get x squared plus 2x. Distributing the 7, I get 7x plus 14. Combine the middle terms. 2x and 7x make 9x, and I get x squared plus 9x plus 14. Now, I'm not going to explain the others in detail. That should remind you of the process, and I do believe you're probably getting these right. If there's any issue with these, it's really important to reach out to me and get some help. X squared minus 8x plus 15. X squared minus 11x plus 24. X squared plus 7x minus 18. X squared minus 7x minus 18. Okay, let's look for some trends here. I just happened to notice in number 1 that 3 times 5 is 15, right? And 3 plus 5 is 8. And number 2, 7 times 2 is 14. 7 plus 2 is 9. Hey, look at that. In both cases, when I added these numbers at the end, I got the middle term. Well, that's interesting. What about on number 3? Well, let's test it. Negative 3 times negative 5 is 15. So if I multiply, I get that last term. And if I add negative 3 and negative 5, I get negative 8, that middle term. Wow, that's a pattern here, right? Right? Number 4, negative 8 times negative 3 is 24. Negative 8 plus negative 3 is negative 11. Oh, wow. I didn't notice this before, but this is pretty cool because that shows me what I must have started with to get the product at the end. Look at this one. 9 times negative 2 is negative 18, so I multiplied to that last term, which was pretty obvious, but what I might have missed if it wasn't brought to my attention is that 9 plus negative 2 is 7. And in the next one, negative 9 and 2 make negative 7. That's pretty powerful. That brings us to what we call the AM method. It means you multiply to the last term. When you try to figure out what you started with, when you reverse engineer, let's take a look at choice 1. X squared plus 8x plus 15. You're going to, you know that it's 2 binomials that you started with, so x and x. The question becomes AM, A going over the 8 because you're adding up to the 8, and M going over the 15. What 2 numbers multiply out to 15 and add up to 8? The answer to that is 5 and 3, and that's why 5 and 3 go in the parentheses. For number 2, it's what 2 numbers AM add up to 9 but multiply out to 14. You should put your first focus on the multiplying because it eliminates possibilities quite quickly. And that would be 7 and 2. So I get x plus 7 times x plus 2. Now, a sad but true state of affairs. There's this thing called the law of unintended consequences. And sometimes when you try to do the right thing, something bad comes from it. An example of that is when students were allowed to use calculators in school. And your generation coming through is not the first generation with calculators, but it's even more. Did you use calculators even more than previous generations? Because the schools are told you have to have it for a test, meaning like at the end of the year and stuff. So you became pretty dependent on calculators. And what that means is that students are not as good at their timetables as they used to be. And they're not as good at their addition facts as they used to be. Now, mind you, if I said to each of you that I will pay your college tuition if you can be perfect on your multiplication facts and your addition facts, you would be fantastic at it in a hurry. We both know that. But that deal's not on the table. So for those who are calculator dependent, more so than have these numbers quickly off the top of their head, I want you to know that you can do factoring on the graphing calculator. And you probably learned factoring back in high school. And I don't know if your teacher told you how to do this, but you can do it. We want to get to the y equals button. If you hit that and then clear everything that might be in there out and go to y1, what you're going to do is put the last number divided by x. So let's take a look at number 1. In this case, you would put 15 divided by x. And then for y2, you always put whatever was in y1 inside parentheses. Please don't miss that here in the bottom right corner, because if you don't put it in parentheses, it can be a huge problem. It will be a huge problem. So put it in parentheses. So for y2, it's parenthesis, same thing as in y1. Close the parenthesis, plus x. It always looks for that. Then you go to table. Don't graph it. Go to table. And when you look at table, in the y2 column, you look for the middle term. In number 1, you would be looking for an 8. When you find an 8, you look at the 2 previous columns, and they will be 5 and 3. And then you can fill them in. Let's take a look at number 4. You would put for y1, 24 divided by x. For y2, you would put parenthesis, 24 divided by x, close the parenthesis, plus x. And then in the y2 column, the last column, you would be looking for negative 11. When you found that negative 11, the 2 previous columns, in either order, it doesn't matter, would be negative 8 and negative 3. So that means your factors are x minus 8 and x minus 3. So you can do the AM method off the top of your head if you're really skilled with numbers. You may have learned it well that way in high school, or you can go to the graphing calculator to help you out. So let's have you try the first 2 questions, and then I'll go over them with you. Okay, so factoring out x squared plus 9x plus 20, I want 2 numbers that multiply out to 20 and add up to 9. Oh, that would be 5 and 4. Multiply out to 20, add up to 9. That's AM. 5 and 4. So that would make the factors x plus 5 and x plus 4. But what if you wanted to do it on the calculator? Into y1, you would put 20 divided by x. And in y2, make sure it's in parentheses, and then plus x. And then you look for the middle term. You look for 9. And then whatever it says in the 2 previous columns on the same row as 9 will be your answer. In this case, it's 5 and 4. For number 9, you multiply out to 20, so m is 20. You add to 12. So what 2 numbers multiply out to 20, add to 12? It would be 10 and 2. So your factors are x plus 10 and x plus 2. Let's distribute back to check ourselves. I should have done it on the first one. We'll do it here. X times x is x squared. X times 2 is 2x's. 10 times x is 10x's. 2x's and 10x's all together make 12x's, which we wanted. And 10 times 2 is 20. With the calculator, in y1, you put 20 divided by x. In y2, put the same exact thing. Make sure it's in parentheses, plus x. And you look in the y2 column for a 12, whatever you're looking to add up to. And the 2 previous columns would say 10 and 2 in either order. Okay, let's see you try numbers 10 and 11. Go ahead. Remember, stop and start. Okay, now number 10, I need two numbers that multiply out to negative 18 and add up to negative 7. Those two numbers would be negative 9 and 2. That makes my factors x minus 9 and x plus 2. Remember, we're reverse engineering all of this stuff. If I did it on a calculator, I would say, okay, I need negative 18 divided by x and y1. This is where it's so important. Well, it's always important to have it in parentheses. Same thing in y2 plus x. That's all you ever do. Same thing in parentheses as y1 plus x. And then you look for the y2 column to say negative 7. Okay? And that would tell you the two columns before would say negative 9 and 2. Let's just check ourselves back. X times x is x squared. X times 2 is 2x's. Negative 9 times x is negative 9x. 2x and negative 9x is negative 7x. Negative 9 times 2 is negative 18. So I got it. For the last one here, number 11, two numbers that multiply out to negative 10 and add up to negative 9. That would be negative 10 and 1. So my factors are x minus 10 and x plus 1. As far as the calculator goes, I would do the last number divided by x. I always like it in parentheses. And then for y2, it better be in parentheses. Parentheses negative 10 divided by x plus x. Always just plus x at the end. The reason I think it's so important to put it in parentheses is because you don't have to have it for the first one. But if you don't have it for the second one, you will get it wrong. So I just get used to putting it in parentheses all the time. And then I don't have to worry about it in y2. So if a calculator is something that really helps you when you do math, the graphing calculator here can do the factoring for you. It's looking really good. Okay, try numbers 12, 13, and 14, and we'll go over those answers. Okay, assuming you did stop and start. In the first one, AM, I'm going to multiply out to negative 40, add to negative 3. You always focus on that multiply first. The two numbers that do that are negative 8 and positive 5. So our factors are x minus 8 and x plus 5, or h. Let's just distribute back and check ourselves. X times x is x squared. X times 5 is 5x's. Negative 8 times x is negative 8x's. So 5x's and negative 8x's add up to negative 3x's. And negative 8 times 5 is negative 40. If I did it on a calculator, y1 would be negative 40 divided by x. y2 would be the same exact thing in parentheses plus x. Okay, number 13, I got to multiply out to negative 12, add up to positive 1. That would be positive 4 and negative 3. My factors would be x minus 3 and x plus 4. If I did it in the calculator, it would be negative 12 divided by x for y1. For y2, same exact thing inside parentheses plus x. And you look for what you look in that last column for the a, what you add up to, it's 1. The two previous columns in either order would be negative 3 and 4. Number 14, our last one for the day. We're going to multiply out to 6, add up to negative 5. That gives me negative 2 and negative 3. Okay. X minus 2 and x minus 3 are the factors. You could distribute back and check yourself. If we do the calculator, y1 will equal the last number divided by x. Always like that in parentheses. For y2, it has to be in parentheses, and then plus x at the end. I look for whatever's in the middle term, in this case a negative 5. When I find it and I look in the two previous columns, I would see negative 2 and negative 3, so I know those are my factors. Distributing back to check ourselves, x times x is x squared, x times negative 3 is negative 3x's. The negative 2 times x is negative 2x's. Negative 3x's and negative 2x's make negative 5x's, or n's, whatever. Therefore, they're equal, and negative 2 times negative 3 is 6. That's the last of the new material for today. Factoring is a real important topic, and we managed to finish it all off. Plus, review word problems. Remember, we spiral our work in here. We always come back to it. If you didn't completely get factoring today, don't panic. We're going to do it tomorrow. We're going to do examples of factoring probably just about every lesson from now until the end of the year. The happy recap. Greatest common factor is you choose the biggest number and the smallest exponent in both cases. What's the greatest common factor of 12x to the 5th and 8x to the 3rd? What is it? Come on now. It's 4x to the third. 2 ways to factor trinomials. The AM method, that's if you're really strong with numbers. And by the way, there are times where I am fantastic with numbers. And there are times when I go to the graphing calculator to help me because I don't know all combinations of numbers. And the graphing calculator technique can help with odd factorings. Like if you multiply out to, say, 238 or 500, there's so many combinations, or 1,000, that the graphing calculator will help you whittle it down right away. In word problems, make sure you underline information in the word problem that you need to use. I often, if I'm doing that, use little check marks as I use it. Drawing diagrams always helps, whether it be the diagram of the rectangle that we did in the perimeter problem, whether it be the diagram for the apples, pears, and mangoes problem. Diagrams are a big help. Don't just read the question and think you got to get it right. You've got to put pen to paper to start working it out. First quiz this week. Check out Moodle for when the quiz is open. Not enough to just do your homework. We have to learn from it. I mention this all the time. This involves not just doing the homework, but grading it and determine where you might have gone wrong. If there are issues, you talk to friends, you talk to me, you send me emails, etc. If necessary, watch the section of the video that's giving you a hard time more than once. That can be a big help. And make sure you're checking Moodle frequently for assignments, updates, and adjustments.